Hello, welcome back to Cracking the Cryptic and a fascinating constructor today. It's Panda. And hats off if you go, oh yeah, I remember Panda's last puzzle. It was 3.5 years ago on the channel. I did a video a while ago where I wondered if this was the longest gap between somebody's first two puzzles on the channel, or maybe their last two puzzles on the channel, but this could have broken whatever record that might have been being set then. April 2021 we featured Panda before, and Panda has come up with a magical clock and sent it to us, and I'm going to have a go at it today. So congratulations to Panda on a repeat appearance at some distance from the last one. I mean, 3 and a bit years is over half the life of the channel, even going back to the really earliest days when we only did 1 or 2 videos a week. Now, of course, we do 2 videos a day, and that is 730 minimum puzzles a year. So 2,500 puzzles will have passed under the bridge since the last Panda. It's brilliant. Well, I mean, that is, pandas very rarely get together, from what I understand from zoo lore. So there we go. We will look at this in a moment. Don't forget that on Patreon we've got the wonderful Skajojobo's Hunt, the CTC clone pack featuring puzzles riffing on their names being so similar, and it's really good fun. Do check it out. There's loads of other content on Patreon as well. It is a wonderful source, as are our apps, which have got some great puzzles in them. I mean, really, in terms of dollars per puzzle, which is probably about 0.25, it is the best value you can possibly pay for Sudoku with. And those are our apps. We have line Sudoku. There are some zipper line puzzles in it later on. They weren't in the first few releases, because zipper lines hadn't been invented then. They hadn't been invented when Panda last featured on the channel. They hadn't been invented when Sudoku Pad was created first. You can get that now, also on the links under the video, and you get our merchandise as well. But I mean, loads of good stuff, as always, around the channel. And I'm going to go through the rules of Magical Clock now. Normal Sudoku rules apply, 1 to 9 in every row, every column, and every 3 by 3 box. Now, these are zipper lines, but there's an extra rule. Oh no, first, there's a big old extra rule about the central box, which is a magic square, which means that every row in it, every 3-cell row in it, every 3-cell column, and every 3-cell diagonal add up to the same number. Now, there's a special rule about the zipper lines, which is that the normal rule is that digits that are an equal distance from the center of the lavender zipper line must sum to the digit in the middle of that line. So that will be the sum of those two, and also the sum of those two. Now, here's the extra rule. You cannot use the same sum to make the total on the same line. For example, 8 equals 4 plus 4, which can be only used once on the same line. Then we have some little killer clues outside the grid. They indicate the sum of the digits in the diagonal they're pointing to. So those 4 add up to 14, these 9 add up to 46. That's 9. There we go. So those are the rules of Panda's, that's his real first name. It does appear if you go onto the link. Panda's magical clock. And I don't know quite how, it does, okay, there's maybe 5 o'clock or so on the clock. Maybe that's the clock, or maybe it's the numbers outside it, which are not very plausible on the 24-hour clock. I don't know. Anyway, we'll see how we go. Do give it a try. I'm going to start now. Let's get cracking. So, the magic square. What's worth considering if you want to consider a magic square from the beginning is that there are 6 different sums of 3 digits that all add, well, in fact, there are 8 different sums of 3 digits that all add up to the same total. Let's first of all calculate what that total is. If we add up the digits from 1 to 9, they come to the magical secret Sudoku number of 45. So if you divide that into 3 groups, they each add to 15. That's normal. So 15 is the n, 15 is the total we're looking for. Now, as well as those 3 horizontals and 3 verticals, we've got 2 diagonals that also add to 15. Now, 4 of these things run through the center using all the other Sudoku digits. And the only way you can make 15 using one number and all the other pairs is with 5 as the common number. So we're putting 5 in the middle of our 5 o'clock thing. Now that's on the zipper line. And okay, I'm going to tell you another thing about 9 and 1. 9 and 1 must appear in this box. But how many different combinations can they appear in to make up a 15 total? And the answer is 2, not 3. 9 can be with 915 or 924. There are no other combinations, and therefore you can't put 9 and 1 in the corners, because the corners have 3 possible sums. So 9 and 1, like the other odd digits, must go in these cells orthogonally adjacent to the central 5. That means the even digits go in the corners. Now, on this zipper, this is 1 or 3. It's got to be less than 5. This is 2 or 4. They are opposite. Remember, this adds up to 15, so that's 6 or 8. This is 7 or 9. Now, can we actually go further? If this is 654, yes, if this is 654, that can't be a 3, or this would have to be 636. So if that's a 6, if this is 654, I can add up the zipper to work it out. So if this is 654, I'm just going to put these in the corners. 654, that's a 1 to make the zipper work. That's an 8. That's a 3. Then I'm just doing my 15 totals, 7, 2, 9. That's one way to make it work. The other way is 852, which is 8, 5 there, 2 there. Now on the zipper, this is 3. That becomes a 4. 4, 2, 9 here. That would then be a 1. What have we got? 8, 1, 6 here. And that would be a 7. So those are the 2 candidates for each cell, and I'm therefore going to eliminate the candidates that I had otherwise marked. They can all go away. Right, so those are the remaining candidate possibilities in this central box. And as soon as we get any one of these digits, we can fill in all of the rest of the central box. On the 46 diagonal, we know that that group adds up to 15 either way round. Which doesn't really help anything. Oh, these diagonals are incredibly helpful. Right. Whatever this zipper line X is, the center of this zipper line, that equals X, because that's the rule on the zipper line, and that equals X. So this line, this diagonal equals 2X, and that's 14. 14 divided by 2 makes this 7 as the total. That's going to work here as well. We've just got 3 cells there. That's X and that's X. 16 divided by 2 is 8. Again, 2 lots here. This is equivalent to that. This is a 9. And 2 lots of the same sum here. So this is a 6. And we get, maybe this is the clock. We get a 5 in the center and 6, 7, 8, 9 going around there. I don't know. Anyway, I was going to say this is a 1, 2, 4, 5 quad, but I have to remember that 3, 3. Oh, there's this rule, of course, about we can't use the same sum to make the total on the same line twice. So this 6 line, this is big. This is the longest line has the smallest zipper sum. That's strange. These are going to be one set of either 1, 5 or 2, 4 here. The other set here are, and also a 3, 3 pair. That's what, sorry, I'm burbling away, trying to say that. Right, the 3-3 pair is not on the ends because of the central box. Remember, these are all the odd digits in the central box. If we were to put 3 there and 3 there, where could 3 go in the central box when those are all ruled out? Impossible. So this is the 3 pair. They're definitely 3s. These are, now we know they're not the 5-1 pair because 5 sees both of those. So that's the 2-4 pair. This is the 5-1 pair here in box 9. And basically, 3 can be placed in box 9. I was going to say we've used these little killer clues, the ones outside the grid. Apart from the long one, we've fully used them effectively now. Now we just have to obey the zipper lines and stuff. Right, this 7. Only one place on it a 3 could go, which is, in fact, 3 by Sudoku is in one of those cells. It could well be there with a 4 here. I can't see a reason that's not the case. Oh, hang on. Think about 2s and 4s in this box. That's quite interesting. Let's give 2 and 4 colours, yellow and red. Now, red doesn't appear there in box 9, so it appears in one of these cells. And yellow doesn't appear there and appears in one of these cells. Now that means that this can't be yellow or red, so it's not 2 or 4 or 3, but it's less than 7. So it's 1, 5 or 6, opposite 1, 6 or 2 up there. This, I suppose, is part of a 9 sum and also can't be 2, 4 or 3. For the same reasons. Now, if I was to write in all the other candidates, they would include all of these, and I don't see how any of them are ruled out, which makes this a bit of a fatuous exercise. Yes, I do one of them. This can't be a 6 because that would be a 3, and that is ruled out. So that's a tiny bit of action there. This pair on the 8 line, no, not really very. Okay. No, it can't be a pair of 1s was all I was going to say, which is a useless deduction. Because it wasn't going to ever be a pair of 1s. Right, what's going on with the 7 then? That looks the next most helpful thing, but I don't know. I mean, I can rule out 6 from this cell and 4. All right, 5, 3, 2, 1 there. 6, 5, 4, 2 as possibilities there. I don't think I'm doing this the right way. I think I probably need to think about the central box again, or the long diagonal. Yeah, hang on, this long diagonal, right. Apart from these purple cells, we know the total, because we know it's 15 in the central box. Plus 9 there is 24, plus 8 is 32. So the purple cells sum up to 14. Can we use that? We don't, I mean, they can include repeats. I don't think it's actually all that helpful. I'm not sure how I'm meant to be proceeding now. So let me think about this. 7, 3, 6. I must have missed something about this box. Ooh. If that was a 6, that's quite interesting. If this was a 6, that's a 4, this is a 1, and now that has to be 5. Oh, this might, yeah, there might be some combination here that doesn't work. That would be 2 in that case, which seems fine. I don't know how to use that, annoyingly. So, have I missed a rule? Why can't I see what to do next? I mean, I'm tempted to put in the possibilities on this 8 line, but there are so many. The same is true for those 9 possibilities there. Oh, here we go. There we go. Bingo. That 3 is looking at that cell. Sorry, took a while, didn't it? That's a 9, that's a 7, that's a 1. We can just fill in the central box. Wasn't that hard. Just needed to see it. Right. Now that didn't resolve this at all. It did take 2 out of that cell. That takes 5 out of this one. This is now a 1-6 pair, and we're not allowed to use a 1-6 pair elsewhere on the line. So this is either 2-5 or 3-4. Now what else has this done? This can't be 1 or 8. So this can't be 1 or 8, and it also can't be 2. So that's a definite 4, and that's a 5. This now can't be a 5-4 pair. I am now going to mark the remaining digits, because this digit also can't be 8 or 3. So it's 1, 2, 6 or 7, leaving this one to be 8, 7, 3 or 2. I'm marking those just because the way this puzzle is working, I keep finding things out which are quite interesting when I do this marking. Yeah, here's 9, has to be in one of those cells. 7, similarly in column 9, has to be in one of those. Oh, there's an X-wing, a virtual X-wing. 6 is there. In box 8, it has to be, well, it has to be in one of those 2 cells, funnily enough, given that we've pencil marked that. And therefore it's not here, and that's not 3. You see, this might yield fruit in a moment. 6 is in one of those cells in the bottom row. And 1, yes, 1 is the same. Well, not quite the same, but 1 is confined to those cells in box 8 and to those cells in box 9. That's going to use up the ones in rows 7 and 8. So that can't be a 1. And now that can't be an 8. And this is definitely a 2-7 pair. And that's going to give me another X-wing thing, another hypothetical X-wing. What do we call it? A virtual X-wing. 7 is in one of those 2 and in one of those cells. That's using up the 7s in rows 7 and 8. So 7 is not here. 7 is here in purple. And these purple cells had to add to 14, I remember. So these 2, let's remove that purple. These 2 are left adding up to 7. I'm just going to check the maths. 10, 19, 24, 31, 39. Yes, these 2 purple cells add up to 7. These 2, of course, add up to 8. Surprisingly, I can't use that. I can place 3 in row 8. 3. 9, 2, 7, 3, 6. Still haven't resolved these yellow and red 2 4s. What's next? And is it as obvious as the last thing I missed? Who knows? Yeah, I'll tell you what's next. This is 9 and red between them, and red is 2 or 4. So 8 is in one of these cells, along with 2 or 4, whatever yellow is. So that's a 2, 4, 8 triple. So these are from 1, 5, 6, 9. That doesn't tell me about this. These are 1, 6, 8, definitely as a triple. And this is a 4, 5 pair, which I can fill in. And that fixes 1, 5 over this side. And now this can't be a 5, and this can't be a 2. And 5 is definitely in one of these cells in the final column. Yes, it is. So that has to be a 3. And that's a 4. And now I'm wondering if I can take it across to this line, the 8 line. Yes, look at this cell. It can't be 3, 4, or 5. So it's 1, 2, 6, or 7. It can't be 1 because its counterpart here can't be 7. And it can't be 7 because its counterpart here can't be 1. And it can't be 2 because its counterpart here can't be 6. So that's a 6. That's a 2. That 6 looks across the grid to that, which is a 1. That's a 6. Almost all the zipper lines done. Now, we're not allowed to use 2, 6 on here. And this can't be 3, 4, or 5. So this is 1 or 7. and that's 1 or 7. And this pair is either 2, 5 or 3, 4. So that digit has to be a 2 since it sees 3, 4 and 5. And that one's a 5. And that has dealt with the long diagonal completely. That 2 doesn't do anything else. 4 is in one of those cells in box 1. We've used all the clues in the grid, I think, now. So now it's just classic Sudoku, I think. That's a 5, 6, 9 triple. So we've got 1, 2 and 8. I can put 2 there. Yes, I can fill those in. 1 and 8, that sorts out the 7, 1 pair. That 7 sorts out the 2, 7 pair. Now every single zipper line, apart from yellow and red, is done. That's weird. This can't be a 2. That can't be 2 or 4, so that's definitely 9. This is definitely red. That can't be 4. This is a definite 8. Let's look up this column. First column is done. 2, 9, 1, 7, 8, 5. That is 3 or 6. 9, 8, 2, 4, 7. That can't be 9. That can't be 6. That can't be 5. Now this column, 6, 7 and 8, I can write them in. 6, 7, 8. 4 is in one of those 2 cells. 3, 2, 9, 4, 6. That is a naked 8. That's going to fix that as 2. That as 4. So red is 4. I mean, I didn't really need the colours anymore. In fact, let's get rid of red and yellow as colours. Because they've done their job. And that's a 9. This is 1, 4, 7. I don't know the order. This is 2, 5, 9. I know where the 2 goes. 8 and 3 in the row. That's a naked 9, so then I can fill in 5 and 2 in the row. This is a 9 to finish the box. Then I've got 5 and 1. That sorts out 6 and 1. This is a 3. Very nice puzzle, this. I mean, not too taxing, but just the right level, I think. 9, 5, 6, and very neatly put together. I'm annoyed it took me 3 minutes, maybe longer, to spot that that 3 was looking at that cell, but that was a while ago now. 7, 8, 4, 3 and 9 up at the top, and what have we got? 1, 4, 7, 7, 4, 1. There we go. That is the magical clock. Thank you, Jerome Panda. And an excellent puzzle it is too. That's the sort of class we get every day on the channel. It's brilliant to see. Thank you for watching as always. Hope to see you again soon. Bye for now.